All right. So we are on week 3 of quarantine notes, and we are going to talk about inverse trig functions, and we are going to talk about kind of just some ways that we can use trig functions in solving problems and such. Really, this week's notes are pretty quick, pretty easy, so that's good because this week you also have your Unit 2 test. So we're going to wrap up Unit 2 real quick. It's not going to be a lot. And then you have your test. The review is up, and you can take your test as soon as you're done with this homework. So whenever you feel ready, go ahead and take the test. Next week, we're going to start on Unit 3. So here we go. Inverse trig functions. We're going to start by talking about inverse sine. And really the trickiest part of inverse trig functions is what you see down there at the bottom, that in order to make the inverse sine function into a function, we have to restrict the domain because sine goes on forever. And so when we flip the x and the y, we want to make it so that it passes the vertical line test. Because if I flip that so that that little S curve goes up and down, it's going to not pass the vertical line test. So what we do is we restrict it and we say we only want to go from negative pi over 2 to pi over 2. And so that little -1 looking exponent on sine is the symbol for inverse sine. And we say that y equals the inverse sine at x. But we're only talking about the y values from negative pi over 2 to pi over 2. So for me, the picture always makes more sense. So we're just looking at the part of the sine curve from negative pi over 2 to pi over 2. So when we flip the x and the y, this is what the graph of inverse sine looks like. So if we want to find exact values of inverse sine, what we do is we look at our unit circle values, really. And we're going from 0 to pi over 2, and then we're going backwards pi over 2. So really we're saying like 11 pi over 6, 7 pi over 4, 5 pi over 3, and 3 pi over 2. But we're considering them as the negative version of those. And so then I know that at pi over 6, sine is 1/2. At pi over 4, sine is square root of 2 over 2, and so on. That's where this table comes from. And so really this table is just telling you the answers. So if I want to know what is the inverse sine of square root of 2 over 2, I say, okay, what angle has a sine of positive square root of 2 over 2? So I look at my table, there it is. So the answer is pi over 4. Inverse sine of negative square root of 3 over 2, I find the negative square root of 3 over 2. And on your unit circle, the answer would be 5 pi over 3. But since we want between negative pi over 2 and pi over 2, our answer is negative pi over 3. And inverse sine of 0 is just 0. So that's how inverse sine works. Cosine is very similar, but we cut it off from 0 to pi. And so all of our answers are going to be between 0 and pi. So they're all going to be positive. We're talking about the top half of the unit circle. So if I want to know what is the inverse cosine of negative square root of 3 over 2, it is 5 pi over 6. Inverse cosine of positive 1/2 is pi over 3. And inverse cosine of -1 is pi. So again, if you have this table, it gives you all the answers. And these are all on your unit circle. It's just the x values of all of these unit circle angles. The last one we're going to look at is tangent, and tangent is always y over x. So these are a little less obvious, but again, they've put them in this nice table for you. And tangent is just like sine, where we use negative pi over 2 to pi over 2 so that we get one full period of tangent. And then when we flip it, that's what it looks like. And you'll notice they don't have the pi over 2's here. That's because they're undefined there. That's where those asymptotes are. And so we're not going to see pi over 2's. If you get that, your answer is just undefined. So negative square root of 3 over 3, I find that my answer is negative pi over 6. Inverse tangent of -1 would be -π/4, and inverse tangent of 0 is a 0. So that's how those inverse trig functions work. They're pretty straightforward, not too difficult. There's only one answer for them, and it's whatever the chart tells you. The next thing we're going to do is solve right triangles. We actually talked about this in Unit 1. It's kind of just a refresher. So you're going to use your SOHCAHTOA, and to solve a right triangle just means you're going to find whatever's missing. You want to make sure that you know all three sides and all three angles. So we're going to look at a couple quick examples of those. So here I've got a right triangle. I know my right angle. I know this angle's 56, and so I need to find angle theta. I know my hypotenuse is 15, so I want to know what is side A and what is side B. So we're going to do the easy thing first. The easy thing would be, what is angle theta? I can find that by just doing 90 minus 56, or 180 minus 90 minus 56. Either way, you'll get 34 for theta. The next thing I'm going to find is A. You can find A or B next, doesn't really matter. So I'm going to find A next. So if I'm looking for A, I don't want to use the theta that I found, because what if I'm wrong? Then I'm going to get that wrong too. So I just want to use 56 and 15. Side A is adjacent to 56, and then 15 is hypotenuse. So I want to use the trig function that uses adjacent and hypotenuse. That would be cosine. So cosine of 56 equals adjacent, that's side A, over hypotenuse, that's 15. I want to solve that for A, so I'm going to multiply the 15 over, and then I can just put that in my calculator, and I get about 8.4. The last thing I need to find is B. So again, I just want to use what I've got. So I've got 56 here, I've got 15 here, and B is opposite of 56. 15's hypotenuse, so the sine function uses opposite and hypotenuse. So I'm going to say sine of 56 equals B over 15. Multiply my 15 over and put that in the calculator, and side B is about 12.4. And now I've gotten all the missing parts, so we just solved that triangle. Cool. We're going to solve one more triangle. This one's a little trickier. I know the right angle, but I don't know the other two. I know this leg is 19.67, and I know the hypotenuse is 37.21. So the easiest thing to find on this one is side A, because we can just use Pythagorean theorem. A squared plus 19.67 squared equals 37.21 squared. Square your numbers, subtract, square root both sides, and A is about 31.59. Again, I don't want to use that number though, because I've rounded it. And also, what if I'm wrong? What if something's gone horribly terrible? So next up, I want to find angle alpha using only these two sides that I know. So 19.67 is adjacent to alpha. 37.21 is the hypotenuse. So adjacent and hypotenuse use cosine. So I'm going to say cosine of alpha is adjacent over hypotenuse. And if I want to get this alpha by itself, anytime I'm looking for an angle, I'm going to use that inverse trig function, that cosine with the -1, to get rid of cosine. So alpha is inverse cosine of 19.67 over 37.21. Type that in your calculator, and alpha is about 58.09 degrees. So then I want to find beta. 19.67 is opposite of beta. 37.21 is hypotenuse. So that's going to be my sine function. Sine of beta is 19.67 over 37.21. To get rid of sine, anytime we're looking for an angle, you're going to use those inverse trig functions. So I'm going to do the inverse sine to get rid of sine. So beta is the inverse sine of that junk. Type it in your calculator. And beta is about 31.91, which guess what? I could have just done 90 minus my alpha there. That should work, but it's a good way to double check yourself as well. So whatever works for you. So that's how you solve right triangles. We've actually done that before, so that should be a good refresher for you. The very last thing we're going to talk about in Unit 2 is probably the easiest thing we're going to talk about in Unit 2, and that is bearing. We use bearing a lot when we talk about sailing and ships and such, so there's me in a boat. So when we talk about bearing, we're looking at like the compass rose with northeast, south, and west. And they'll give you your origin, which we usually use O for origin. And then they'll give you a point, and they want you to find the bearing. So we want to do the bearing from O to B and the bearing from O to A. So let's do A first. So if I want to find the bearing from O to A, we usually use north or south first, and then east or west. So to get to A, I need to go north, and then I need to go east. But I need that angle in between there. So just like it says here, we need the angle before we find the bearing from O to A. Well, if this is 20, I know that this angle must be 70 because it's 90 degrees altogether, right? So from O to A, I'm going to go north, and then I'm going to go 70 degrees east. And so that's my answer right there, north 70 degrees east. You always put your north-south first, and then your degrees, and then your east-west. So if I wanted to find the bearing to B, I'm still going north, so it'd be north 40 degrees west. If I wanted D, it'd be south 25 degrees east. C would be south 15 degrees west, because that's 75 there. So that's how bearing works. Hopefully that should be some easy points for you. And that's it. That is the end of Unit 2. So from here, you should be set to complete week 3 homework on my math lab. Once you're done with that, you can take your Unit 2 test. There's a review up on my math lab if you want to do that to get ready. And then you can take your test whenever you're ready. Make sure that you take pictures or scan in your work and send it to me so I can give you partial credit. You guys are doing so awesome. I am so proud of how well you're doing and how much you're making this work. I know that this is not the easiest way to learn, but you guys are really making it work for yourselves. Make sure that you let me know if you have questions. Send me an email, set up a Zoom time, whatever you need. Unit 3 is where things get a little bit rough. And so I'm glad that we're leaving ourselves some time to get through Unit 3 because that's going to be where we want to kind of slow down and take our time. So good job. Keep it up. Let me know what you need. And I have faith in you. You've got this.